Hey everyone, today we're going to be looking into what the coefficient of determination is. Just to start off with our objective, we're going to seek to understand what the coefficient of determination is, we're going to understand how to find our coefficient of determination, and we're going to seek to realize and understand the importance and the application of the coefficient of determination. Our coefficient of determination, or R-square, is a statistic that measures how much of the variation in the response variable can be explained by the linear relationship with the explanatory variable. If that's a little complicated, we can explain this in a little bit of a different way. The R-square looks to measure how well the explanatory variable explains the response variable, or how accurate our model is. Another thing to keep in mind is that a range of possible values for R-square is typically between 0 and 1. So how does the R-square, or coefficient of determination, work? So here I drew up a mock data set of housing prices and square footage. So what we're going to do first, we're going to look for our mean housing price. That's going to be symbolized with our Y bar, and we're just going to draw a straight line through our data set. So this is our mean housing price, which is around $500,000. And we're going to take each data point and we're going to find its distance from that mean, that Y bar line, and we're going to square each distance and we're going to add them all up. And what that is going to give us is our sum of squared residuals for Y bar. Next step, we're gonna draw another line, and this is our least squares residual line. So this line is going to be the line with the smallest amount of distance between the data points from the line that we drew. All right, so we're gonna do the same thing. We're gonna take each data point, we're gonna find the distance from our line, we're gonna square those distances up and add them, and we're going to get our sum of squared residuals for our least squares residual line. Next, we're gonna look at our equation for R square. So we're gonna take our sum of squared residuals for Y bar, that's 110,243.7, and we're gonna subtract that from the sum of squared residuals for our least squares regression line, and that's gonna be 20,312.6. Finally, we're gonna divide the difference that we find by the sum of squared residuals for Y bar. So if we plug those numbers into this equation, we're gonna get R square, or a coefficient of determination, of 0.816. So now we're gonna figure out kind of what that means. So if we have an R square value of 1, that is saying that our explanatory variable explains the response variable perfectly. So 100% of the variance in the response variable is explained by our explanatory variable. Now, if we see an R square of 0, then our model would show no difference in predictability from the mean of the response variable. In other words, there's not going to be any real relationship between the explanatory and the response variable. In our problem, though, we found an R square of 0.816. What that means is that around 81.6% of the variance in housing prices would be described by the square footage of the home. So if square footage is our explanatory variable and price is our response variable, around 81.6% of this variance would be explained by the square footage of the home. Next, we're gonna dive into why the coefficient of determination is important. So first, the R square allows us to compare linear regression lines. So if we have a bunch of different regression lines and we're looking for the most accurate one, R square is going to be a tremendously useful tool for us. Next, R square gives us an easily interpreted way to measure correlation between variables. So R square is a very simple measurement to look at. It's always going to be between 0 and 1, and it's a very objective measure. No matter what variables we're looking at, the size of those variables, it's always going to be between 0 and 1. So we don't really have to contextualize that variable too much. Next, the R square helps eliminate bias where we might see faulty relationships between variables. So it's going to eliminate human error. Just to review everything, the coefficient of determination is a measure of how much of the variance in the data is explained by the explanatory variable. Our possible range of values for R square is going to be between 0 and 1. An R square value of 1 represents a perfect relationship, while an r-square value of 0 represents no relationship, and r-square gives us a simple way to compare models and their accuracy. Thank you very much. These are my sources. I hope you learned something during this video and hope to see you in the Aggie Math Learning Center.